right? So that's that for this. Let's go ahead and move on to the next module. So we have our entities, and we're using our entity in here. You can see we're passing them around inside of this layer. So next we have our use cases, directory use cases. Now inside of the use cases, we will create a file, we will create a module for each functionality inside of the repository. Alright, so if we have the create user functionality in here, meaning that we will have a use case for the create user. Alright, if we had one for get users, we will also have a module for that one. Alright, so let's go ahead and do that. So create user, we will call that class create user, right? And this create user will be create user. And now this is where the fun part comes in. So how is this create user going to work? The create user will be depending on the repository, all right? In this case, we have our authentication repository. It will depend on it and it will call the create user from it, all right? So this facilitates the single responsibility principle, all right? So in this case, we're depending on this dot repository, all right? And in our repository, I'm making that a private because I don't want someone else to be able to access it, some other class to be able to access it. Remember, single responsibility. So this use case only has one responsibility. In this case, this person, this contract doesn't have one responsibility. It has more than one. It has create users, get users. But this isn't wrong because this is just a contract. All right. So this is actually where we bring in the actual single responsibility. So authentication repository, and we take that and we can create the function again. I think the function we're doing is create user. So it will be result void, right? The same as result void create user. It will take all of these. So let's go ahead and paste that in here. So it will take all of that and it will simply async, and it will, because the other one's a future, all right? A result void is basically a future. You can see right here. So we can do that and say async. We can just call the repository.create user and we pass in everything into it. Alright, so this is basically how the use cases should work. But now every use case, right? Every use case is going to follow this same pattern. Alright, so again, we're going to do another abstraction by creating an interface. Alright, so this is how all of your clean architecture project will be structured. Alright, so every use case will simply carry this out and carry out the actual functionality that's related to it. Alright, so what is it implementing, or what functionality is it implementing, or what is it going to call? Create user. So we will always override it. So let's create one interface in order to make sure that every single time we create a use case, that use case will follow the same pattern. So this is what the point is with clean architecture. We want to make sure that everything is going to be exactly how it's meant to be. We don't want to leave any room for mistakes from ourselves. So clean architecture is basically you saying, I don't trust myself as a developer. I know that I'm prone to mistakes because I'm human. So I'm going to create ways to stop myself from making mistakes. All right. So we create a repository and we know that every time we want to call a create user, we know that by force we must pass in these three things, and by force we must pass them in. And we know that by force we will always return a void function. So this is what we're doing. So in this case, we will do this repeatedly for different use cases. So in that case, we can go into our call, create a new data file, put it in use case, the use cases folder, and we can create use case.dart. All right. So now we could have two different types of use case, right? We can have a use case that has parameters, and we have use cases that don't have any params, right? So let's go to our repository. So we can see this use case has params, and this one doesn't. So if we go ahead and say we have a class, let's make an abstract class. class use case, all right, and we go ahead and do this, and we know that each time a use case will return a result future, and it will take some type T, right? The type, all right? We don't know the type, so this is us creating an interface. The interfaces use generics, all right? Generics meaning we don't hard code what they return because a lot of different modules will be using them, so we don't know what those modules might want to return, all right? So result future has a generic type T, right? And then it will have a function called call. So in Dart, the call function exists almost in for every function. All right. So for whatever function you have in your Dart file, all right, you can say that function dot call, and there's this in there, right? So for example, let me show you what I mean. Let's go over to the Dart pad. Let's say that I had a function, right? A function, you know, let's say that I had a function void create user, right? And it does something. Over here, we can simply say create user dot call. You can see. So this will actually call this function. Alright, so this is most useful in such cases where, for example, in your widget, if in your widget you're taking an unchanged property, you know these unchanged stuff are functions implicitly, right? So it's a void function, or it could be a string function, or whatever type of function. What if you don't give it an unpressed? Then the unpressed is nullable, right? So how do you know if unpressed is nullable? If you did this and you said if it's not call, if it's not invoke it, if it's not null, don't invoke it, then that wouldn't work with the question mark because this isn't how Dart works. This isn't a correct syntax. In that case, what you would do is this: you say create user dot call. So if it's null, call this. If it's not null, call this. And you see that it tells us that the receiver can't be null because this is a nullable, right? So if we're passing it as a nullable value, then we can do this simply. So basically, all I'm trying to say is implicitly, every function has a callable, a callable call. I don't know what to call this. It has this little thingy. So now that we know that every function has the call functionality, this is what happens, right? The call functionality simply tells Dart that this is callable, that whatever object has it inside of it is callable, right? So also for our classes, imagine that we had a class, right? If inside of this class we had a class, let's see, callable class, right? And inside of this class we had a function, let's see, void print hello. And this function will simply, not async, sorry. It will simply print hello world. Right. So if inside of this callable class we said callable class dot print hello, right? This simply will print hello, right? Because of this would work. But if we went ahead and changed this function's name to call, then do you know what it means? It means that this object, this callable class, is now callable, right? So whenever I invoke this class this way, whenever you do this, right? Whenever you do this to an instance of this class, rather, yeah, that instance of that class will simply call the call method, the call function in there. So we can see if I save this, final callable class is equal to this, and when I do this, callable class, and I do this, this would work. This works. Do you see? There's no errors, right? An instance of a class is callable. We can run, and we can see that this will actually print hello world. All right. So even if it takes stuff like string message, I'm going to say this dot message. I'm just simply passing the the best tech. And we can see that, right? So the instance is callable. So we want similar functionality for our use cases. Why? We want such functionality for our use cases because we don't want to have to say use this use case dot call, or sorry, this use case dot create user, or this use case dot do this or do that, right? So but conventionally we will use the callable object, right? So we make a callable object by doing this, right? So also remember that some of our use cases need parameters and they need arguments or whatever in them, right? So how are we going to take care of such cases where some need it and some don't? We can create two different use case interfaces, right? So you can say use case with params, right? And we can take the type in the construct, in the declaration, and the params in here as well. So this will be the type, and this will be the params. So let's go ahead and make that type, right? And then the params will be params. So the type is a params type, right? So it will be of this type params. The return type will be of type. The parameter type will also be of type params, which is just a generic type we've defined, right? So we can call that params as well. So we have this, right? So we have a use case that has parameters and it returns the type. We can also have another version, use case without params. We have only a type in this case, and we can have result. Sorry, oh my days. Result future type